Basically what I wanted to cover today is the identity crisis with magnesium oxide cements around the world. On the 1st of February, it's 11 years since I started this company, and it's been an interesting journey to say the least. And the aspects I want to cover is because I find that there's a lot of confusion within the magnesium oxide board industry itself. They don't know whether their product's been around a long time, they don't know the application of their products, and they even don't know the science and that's required to make it work. There are a lot of unisons between fibre cement sheet manufacturing, like the manufacturers that sit here in front of me, and making that a magnesium oxide board as well, as in a magnesium oxide cement. I should stop saying board because that's where the confusion also starts. They think it's board, it's actually a cement as well. Okay. A little bit of history as we go, so that's about me. I'm going to try to push through this as fast as I can so we do get to the beer on time. To many people, surprised magnesium cements and the use of them in the building construction industry is not new at all. In the 21st century, we'll be led to believe by industry experts, university academics alike, that this is a new phenomenon breaking global markets that will revolutionise the building and construction industry as we know. These industry experts also make rash statements that are causing nothing but confusion within the construction industry, such as, it's new technology, it needs more evaluation, don't go near it, it has no proof of performance. Well, what the industry, laboratory, academics and experts are saying could not be further from reality than maybe that of our politicians, but that's another topic, so we won't go into Brexit or Australia, or maybe impeachment with the USA. This unknown innovative material is magnesia cement, or better known as MGO or MGO board, all of which, regardless of the 21st century name, has over 800 years of documented history on successful use in the building and construction industry. So how can this be new? How can there be no proof of performance? Blends of magnesia cement have been used extensively throughout ancient times in Germany, France, Italy, Mexico, Latin America, Switzerland, India, China and New Zealand, among other countries. History shows that ancient European artisans used timber framing filled with magnesium oxide cements to construct homes. Sometimes the magnesium cement had straw bindings within it mixed to allow them to gain better all year round thermal performances from heat and cold, as well as to bulk up the infill mixture. Also, many of the stupas, including the Great Stupa of Sanchi, India, the Pantheon in Rome, were all made with magnesium cements and are still standing today. But believe it or not, there are no gaps visible in these 800-year-old walls and buildings that still remain standing and operating in 2020. Early magnesium cements were made with soluble phosphates and animal feces, or fermented plants and magnesium optical clays. These natural magnesium cements bind naturally exceptionally well to all cellulose materials, i.e. plant fibre, wood chips, etc., and were often referred to as living cements. There is a book out there just referenced away from this called Breathing Walls, which is quite interesting. It's written by George Swanson. If we change the word living cement to breathing walls, it's a reproduction of what was known many years ago. This is a sharp contrast to Portland cement to today, which repels cellulose. The statement, it never goes out of fashion, can be applied to the on-again, off-again evolution and status of magnesia cement, MGO-based products. The global construction materials history historically is based on an extremely wide range of materials such as drywall, plasterboard, OSB and fibre cement sheet, FC sheet, all of which came to fame in the late 20th century as common use materials within the construction industry, of which Portland cement has been the more dominant material. With the push for increasing environmental sustainability and the need for products that deliver higher level of protection from fire and extreme weather events, we are now witnessing a renewed interest in materials that for decades have largely a niche or best curiosity value opposed to gaining commonplace recognition and use. This has led to research into information that has been archived for centuries, which document the vast uses and benefits of magnesium oxide as a sustainable building material. The results of this is that magnesium-based cements, integrated with more recent advancements in modern technology, manufacturing, high levels of third-party quality control and proven in-field performances of high-performance magnesium cement products has industry leaders focusing more on utilisation of magnesium cement products to future-proof their projects. Magnesium cement products versus Portland cement-based products. The carbon footprint, which we've heard about today as well, which is improving, but nonetheless it's still an important factor in sustainability. The carbon footprint of MGO cement is not dependent on carbonisation during use. Its footprint is achieved during manufacture by the combination of the following features. Use of magnesium silicates minerals, which eliminates the CO2 emissions from raw material processing. Use of a production process that not only requires less energy but also lower temperatures and allows the use of fuels with low energy content or carbon intensity, e.g. biomass. Use of hydrated magnesium carbonates in the cement composition that absorb CO2 during their production and therefore have a carbon neutral footprint. Current calculations estimate that the carbon footprint will be a range of minus 100 kg CO2 to plus 100 CO2 tonne magnesia of cement. Portland cement, the ongoing search for alternative materials to that of Portland cement because of its large CO2 emissions footprint of around 80% of global anthropogenics, that's a good word for this afternoon, greenhouse gas emissions has led to the magnesium cement being identified as a potential low CO2 alternative to PC. Here's a graph in here. Look, it looks better up there than what I've seen on my printout. So basically what this does shows the rate of CO2 gases and that in various different products that are there. If we relate back to magnesium, we're talking plus or minus 100. We'll go here and we'll just go straight into fibre porous board for 425 to 1,531. The rest can be seen up there. It's pretty explanatory. If there is any other updated data that I don't have on CO2 emissions with fibre cement sheet, I would be happy to see those as well. So all my documentation is factual. You can see in the magnesium oxide boards here, the graphs in the middle showing either worst or best in performances. The environmental impacts, which this is changing, but mainly because most magnesium oxide cement boards are made in China. There are manufacturing now in Turkey. There's 4 facilities there. There have been several other facilities tried to operate unsuccessful. But if we use this data here, the worst of the CO2 runs in because of the manufacturing and then the shipping and export out of China. The embodied energy is zero. Waste generated is based on typical single sheet wall, so it's actually quite good. When we get into plasterboard systems, if we look at fire-rated wall systems, we're using anywhere between a minimum of 50 up to 60 to 70% less material than a plasterboard wall system to produce a higher performing wall system in all aspects. Okay, a lot of people just get their heads stuck around magnesium boards as a non-combustible board. When we talk about mold, impact, thermal resistance, CO2s, one thing magnesium cement does, it actually trumps everything to do with plasterboard. It falls very much in line with fibre cement as we know Portland fibre cement. So little differences in there which change their performance, but when it comes to performance in wall linings and reduction of materials going to waste, it's a high performer. When we look at energy efficient, air control layers, resistant loss of energy through shrinking expansion. To give you an idea, shrinking expansion at minus 40 to plus 40 is less than 0.25 of a millimetre. Okay, so it's very dimensionally stable. Later goes into materials use. I'm just going to skip through this. Sources and availability. Magnesite has been mainly in China, and there is good resources for the binders and that readily available. And that's whether the manufacturing was in Turkey, America, or China. The complex why there isn't manufacturing in those countries successfully is because people don't have the science or the backing of the science and technology to make their magnesium boards work. Okay, building code compliance, that has been an interesting factor of our whole industry, and most magnesium oxide board companies be them good or bad, sadly, still meet a minimum criteria of zero combustibility. Therefore, they fall into an exemption sort of code that allows them to be used. My place, as I go through this, I just dialogue off this a little bit. The warning to my industry and to everybody that sits here, and anybody that's in the magnesium cement industry that's standing in front of me too, is, and I'll point out here shortly, not all magnesium oxide boards are the same. Just because they don't burn doesn't mean they perform. Okay, so I'm sure you gentlemen and ladies have been through that with the fibre cement sheet manufacturing as well. Thermal mass. This is an interesting topic here, and I have discussed this with a couple of people today, which has been interesting. The forum actually has a very unique, very close nature in what people I've spoken to so far today, and one has been thermal mass and sustainability. Thermal mass and coefficiency plays a role in sustainable projects and are critical in delivering a high levels of fire protection. There is a strange word that is overlooked in many cases through our global building codes and is rarely used in the assessment of sustainability of projects. That word is calorific values. Calorific values are applied to materials based on the amount of heat released by unit weight or unit volume of a substance during complete combustion. With zero being the best, the following graph shows where Rescom high performance magnesium cement board sits to that of other building materials. So you can see on the graph there, if we go down in stone and solid Portland cement and glass range in the line of zero. Rescom board, and I do apologise, it's the only one I have, and it's my company's production, so I do apologise, but we know that our calorific value is between 0.1 and 0.25. We run down the graph there and it only increases. So the higher the number, the worse the calorific value. How does that reflect into our systems? Calorific performance of products has come under scrutiny in independent testing carried out in Canberra, ACT, Australia, of leading suppliers of fibre cement sheet barrier protection boards. These tests further highlighted the risks associated with products that have medium to high calorific value scores. Okay, so with medium to high calorific value scores. The test rig 1, which is on the left-hand side as you're looking at the screen, it will remain nameless of who the companies that were tested for good reasons, but it failed in just under 7 minutes. There was another test rig tested the same by another company at the same time. There is 2 of these others at each end of this room. It failed in just under 8 minutes, and they're the 2 leading companies supposedly in Australia. This shocked the authorities no end when they seen that, and I'm talking the ABCB, the Queensland Building Codes Commission. A lot of leading authorities and fire engineers attended these tests. I wasn't aware of what the importance of calorific values was at that time. Does anybody understand calorific values in the room? That's important. I supplied a test from Spain, just happened to be on this day, for our BSEM standards testing for British, Europe and for UAE. And I get a message back from the structural fire engineer saying to me, what is this calorific value? How long you had it? Well, I've actually had calorific values sitting in my stuff for nearly 9 years at that time. And I asked him what he meant by it, so then he sent back the graph. And he said the reason behind the explosion of that picture there, it wasn't just a crack, it exploded. It shattered the people witnessing the test with fibre cement sheet, was the inability of the fibre cement sheet to absorb and release the energy from the heat source. So it just heated up and just exploded. Where on the other side here, this is a test that was carried out with our Rescom 6mm magnesia cement, and after 35 minutes, it still stayed in place. Okay, I don't know how to make it go back. But it does. Sorry?
Just use the back arrow.
This one? Up, yeah, that one there. It stayed in place, and that was an interesting lesson for me. And then I took that lesson, and I thought this needs to be applied into our holistic building systems, because we need to then look at what calorific values does. So if I can go forward, Whereas independent tests in the same rig, Rescom high performance 6mm magnesium cement board, lasted over 35 minutes without catastrophic failure. When we look deep into the science and performance that surrounds the importance of calorific performance in various products, it opens up a new exciting world of innovative applications when combining these zero to low score value products into holistic building systems. High-level structural engineers have accumulated structural information that is extremely damning on systems that have a higher calorific value than 13, and are now looking to have the findings benchmarked around the world. The risk associated with using these products in construction is extremely high due to the failure of the products to structurally perform when exposed to heat sources. So I start analysing building systems because I don't believe I just own a magnesia cement company. I believe I have an obligation to holistic building systems when you're applying the magnesia cement product to it. So we take a little bit of a different line. No doubt the bigger companies in this room that do take the same holistic value. So I wanted to apply that holistic value to factual building systems and see where they landed in this not more than 13 figure. I took, for example, and I was talking to somebody earlier on about Den's glass, and I applied, which is used immensely in America, and I applied Den's glass has a calorific value of 10. The glass wool insulation then put in, this is a standard really based system, has a calorific value of 6. The system value is 16. Now, when we start walking around and looking at these buildings that have got these, that it says don't put above 13, we've got a responsibility then to make sure that, wow, 16 doesn't work. So I advise anybody using our product plus our distribution agents around the world, A equals B equals C must be below 13. Okay? Example 2 of innovative disruptive technology, the combination of Rescom Performance Magnesium Cement in a wall system will deliver a low calorific value, therefore delivering greater level of all-round protection. So I did 2 comparisons here, once again straight against Den's glass. So the Rescom board, calorific value 0.25, 6 to the glass wool insulation, it's a 6.25, that's a long way below 13, okay? Then I did the other, and I put rock wool. One of the gentlemen I've spoken before is doing rock wool, and that's what should be mineral wool, rock wool should be used in all fire type walls and not glass wool insulation. But also, if we look at rock wool and its ability, its calorific values is 1.3. So 1.3 and 0.25, we're looking at a 1.5 calorific value. That's amazing. Like, that's literally this little panel here, that with rock wool and a 10mm board either side, is delivering a system that is what, 500, 600% better in calorific value, so its ability to resist heat and cold. So the outcome of that is our buildings are easy to, it costs less money to heat them and less money to cool them down. So we're looking at our holistic sustainable building. So I'm not just playing around with magnesia cement, I also want to make sure we're looking at our system. So we can apply fibre cement sheet this way, guys and ladies, no problem, and we'll actually become under 13. Okay? So sustainable building and construction is a really important thing in our whole lives these days. So that's why I want to raise to you the importance of calorific values, and I hope that's knowledgeable to those people. Comparative chart. So I wanted to do a comparative chart here on the performances of 22mm fibre cement sheet, compressed fibre cement sheet, and the same as in the magnesia cement sheet. You can see the information is there, and there's the amount of testing that's available on the magnesia cement sheet at the time of producing this, and what's available on the magnesia cement. MPA categories, when we look at structural performances and that, and I hear that getting mentioned a few times in discussions today, but MPA value of the 22mm structural flooring and magnesia cement structural flooring in my side of the industry is probably one of the largest selling products. We document a 14 MPa as an average MPa. We run in between 14 and 23 MPa for the same thickness against the 7 to 9 MPa. Our densities, we're running densities around about 1,000 to 1,100, where we're looking at the same product at opposition in 930. The big things is where we come to water absorption and changes. Where we documented this, we looked at the fibre cement sheet at 42.7%, and we were at 13.2. I'm happy to show that, and I was talking to one of the binder guys earlier on. This is our latest, very, very latest. The first containers are only now just gone into America. But this now, we've got our technology for the magnesia cement to 3 to 5% moisture content absorption. You can leave that in, you can leave it out, you can leave it in for the next 10 years. It won't be above 5% moisture absorption content. So the magnesium industry now, in my sector, I can't say for all, we have been focusing a lot on the improvement, especially for exterior use and those type of things, performances, to reduce maintenance and reduce having to pre-seal or clean or whatever else. And most importantly, have a product that can be put on a building and we don't have to go and seal it before the bad weather comes, which we've got pretty much a lot of that in Australia at the moment. So if anybody wants to feel and see that, it's a cement board. But happy enough to share it with you. I won't share the IP with you, but I'll share the sample with you. Okay? So, and if you want any of this information too, I do have some folders up the back there. It's got the presentation sheets and that as well, so you want to have a look at those. Okay. All said and done regarding the abilities of magnesia cement, the big question still lingers: are all magnesia cement boards made equal? Do they all perform the same? What types of magnesia cement boards are there? What proof is it that supports the claims of performance? Sorry. Robert, could I have a glass of water, please? Sorry. The simple answer is no. No, they're not all made equal. No, they don't perform the same. And there are at least 6 types of magnesia cement boards that I'm aware of. MgO chloride activated boards is the oldest and longest proven high history of performance in the industry. Thank you very much. MgO silicate board is the most used form of cement, magnesia cement board. And those in the room will know a product called Promat board. Very well known, very well respected around the world. That's a magnesia cement silicate board. MgO Portland cement boards are not used as much anymore because really the Portland cement or fibre cement sheet industry dominated the magnesium side of it many, many years ago. Phosphate boards are the same, but very brittle and don't perform anywhere near as good as silicate or the chloride activated boards. The big bad wolf in the room is the product called magnesium sulfate board, which only has come about over the last 5 years. It came on the back of the Denmark and Sweden claims of rust and corrosion. Everybody's aware of that. I did present some of that information in 2018, and the propaganda that surrounds the Denmark and Sweden issues. Happy enough to open the discussion about what was true and what was untrue in those reports. Magnesium sulfate board got on the propaganda wagon, and that's where they became known in the industry. We do not rust, we do not corrode. Well, what else do they do? They didn't know. We proved testing in testing laboratories, but we had no proof of what it did in the marketplace. So we kept our mouths shut. Today, sadly, we have a lot of proof in the marketplace of what magnesium sulfate boards do. In the east coast of Queensland, where I live, there's over 100 buildings falling to pieces now. It's not a building system problem that happened like in Denmark and Sweden. You don't use drywall screws on the outside of a building, they're going to rust. You don't put a building up and don't use a vapor barrier wrap around your building. You're going to get water in your cavity. You don't use glass wall insulation that slumps when you've got moisture content going into a wall as soon as it's below 23 degrees differential inside and outside. never will the University of London stand in front of me and discuss Denmark, because they are legally responsible for a lot of bad reputations to CemBoards. Okay? So, and I won't hold punches. So when we talk about boards that got propaganda getting forward, sulfate boards is probably the fastest moving MGO board in the marketplace in the last 45 years. They've been around 5. Okay? So what's happened in the magnesium here? So I said I will back my claims by tests. I am now questioned and asked to attend forensic investigations that are involving magnesium boards around the world. So how do we do that? We take them, we test them, and we'll even put them side by side ours, and we're not too proud to show the results and what they come. If we look at the results here, you can see one graph over here, sulfate board, and we look at the same thickness as the rest on side by side. Both of these are tested by independent testing laboratories, so there's nothing untoward in there. We start looking down in the flexural performance straight away. We can see that there's half this difference in amongst that. We look at the moisture lineal movement, there's a huge difference in that to us as well. Then we look at all these other reports that are missing, and we've reported those over here. We come down to falling impact, and these are like all these stress things. Okay, we're not talking about fire now, we're talking about stress. You know, do these boards stand up structurally in the building industry? Should they be used in construction in the building industry? You know, we've got a board that failed the falling ball impact with 950 millimetres. What's this, about this high? Okay? Where high performance magnesium cement, they stopped testing at 3 metres and couldn't break it. These are the things and the awareness I need the industry to be aware of, that not all magnesium oxide boards are made the same. Okay, and really demand that you see the information if you know about them. Look at the screw pull-outs, 446 Newton compared to 3,845. I don't know which one you want your screws hanging out of. Okay, so that's one test report. The second test report you'll see here, this was carried out for an American company that had huge issues with a product called M4. They told everybody it was a sulfate board. We also know that the percentage of mixture of formulation is critical in the science and the performance of any type of magnesium cement. Same as Portland cement, and when you're making your products, your science is critical to make sure it's there. Their claim is there's no magnesium chloride in their magnesium sulfate board. Little round circle. 4.30 chloride residual. That shouldn't be above 2 at best. Okay? I won't go over the rest of it. I tested it 3 times because I thought my laboratory must have mixed up the samples of somebody else's board. Until my business partner told me to stop picking on him, he was testing the right material. Okay? But these are the propaganda. This is the sulfate board resting on the back of something. But what this told us, because we already knew their formulations don't bind. You know, when we're talking about binding here, okay? What's the binders? How are they binding? How's the science coming together? How does it give us all the structural performance? We know that magnesium sulfate in the formulations does not bind. It does not bind. Okay? We've proven it in testing the strength time after time after time after time. I started doing it for free, now I charge. Because I can't keep reporting the same thing for free. Okay? So now we're knowing that they're putting magnesium chloride in the mixture to make the strength of the board, but not telling anybody. But they're overdosing the mixture. Does that make sense? So it's an important factor. I don't mind dobbing everybody in my industry. Okay? I'll tell the truth. This here is the one that really caused the big issues with the failures within the southeast corner. You can see here again a sulfate binder board. I had to take the address. I think I accidentally left it still in there somewhere. No, I left the suburb in there. We used they had a 9mm board. We don't make a 9mm board, but get a go of this. Where you've got our 9mm board down on the side, where it says MgO chloride plus binder, That was our packing strips. That was from around the packing, okay? It had been laying out in the rain and the grass for over 4 years. But it still outperformed this brand new board that was used on structural insulated panels that's now falling to pieces in 100 houses in the southeast corner. So again, we can see the results on sulfate board. The above examples state the highlights and major differences of magnesia cement boards and the importance of ensuring the correct formulations, quality of raw materials, manufacturing processes, independent third-party QA is carried out to lessen both the long and short-term risks associated with buying a product that does not carry the level of proven performance and protection and project needs. This is the good, bad and the ugly part. Hope I point to the right side. The ugly side, the other side. Somebody probably looked at me and said I'm pretty ugly too. The ugly side. This is basically here. That's the panel I'm talking about. There's 100 buildings falling to pieces. This is it cutting up, getting tested. This up here is an Australian company that used to buy a lot of product from me. So then they decided they would go to a Chinese manufacturer and buy it, and they did a big project in the Philippines. The director of the company rang me up and said, Steve, we've used your board and it's falling to pieces. I said, well, you haven't bought board off me for 5 years. That's what they get when they went around the corner and go to buy a board, because it was between $8 and $10 US a board cheaper. I said, don't you think there's a bloody reason that my board's more expensive? It's the materials you use, the science you use, and do you have product liability insurance and various things like that. That's what happened. Here we look at the MPA difference between testing between the magnesium chloride activated board, Rescom board, and the sulfate board. And I don't know if you can see this picture here clearly. This is where we started. This comes from a client in New Zealand. Here's our board he's been trying to kill for 3 years. In and out of water, trying to kill it. There's 3 pieces of sulfate board from 3 different companies that he had in and out of the water for 3 months. They're growing stalactites out of them. So we proved this in an environmental test years ago, which I tabled for you guys back in 2018. Now it started coming from the client, and then from the client again, and again and again. So I just want to make sure that everybody knows that it's not me that's just saying it. It's the proof that's now saying it. Okay? The others here are projects that are getting built in America with SIP panels, Australia. I don't know how many thousands and thousands of projects we are in now around the world successfully. Here is also the manufacturing, the good and the bad. Okay? I like Bert's presentation and going in, and also some of you other guys have told me over time, there's a curing process, there's a drying process, a moisture process. I hear the same thing all over, okay? I hear it from the professionals. You're telling me what I already know that we have to do, okay? Here is the controlled drying process. It's pretty cool, eh? Do you know that it's important to be no more than 2 degrees up or down in the curing process of a high-performance magnesia cement? 2 degrees up or down. If we're 2 degrees up or down, and I'm telling you in summer, when it gets too hot, we close the factory because of the temperature, even our curing rooms, see our curing rooms? Running down here, each side. That's our factory up the top here. Okay? When the temperature gets too high in heat, we shut the factory down because we know the curing process will be too fast. Okay? We don't have that problem in winter now because we've got gas heating and temperature control. But in summer we do have problems now with the temperatures getting way out of control. So, you know, the importance of understanding our science, understanding we also need to cure board. We also need to have time activation. We also have a dual curing process. Where step 1, demolding. Okay, take it out of 1. Step 2. Step 3, then we have it in between cut process, sanding process, and step 4. Even when we know that it goes into packaging, it cannot be wrapped and packaged to a customer until we get past a certain amount of days. In the fibre cement sheet industry, tell me if I'm right or wrong, you use a word called green. Okay. Do you think I use a different word? No. 99% of people from the magnesia cement industry don't even know what the word green means. Okay? So we know that there's a period of time, even after the board is shipped, by the time it gets to our customer, that it probably hasn't met that exact day of its top performance level of dryness. Okay? That's why we also then test every single batch and every single process all the way through. So the bad is what you're seeing probably 98% of manufacturers of a magnesia cement board. And what you're seeing out in the yard there is typical of your magnesium sulfate board companies, because they tell you they don't have to cure the board. Okay. As I've shown you, the magnesium cement industry has been around for over 800 years, so why is it not grown to the status of other leading industry products? This, I believe, is due to some of the following reasons. The modern day groups are continually reinventing the wheel without respect to or understanding of the proven science and complexity of making high performance product. They just think because it does not burn, it's fine and it will fix the problem. Especially after Grenfell, Dubai, Australia, magnesium board is just in the market now. It's just flooded. Guess what? It's not all the same. Supply companies are trying to compete with the entry-level plasterboard and fibre cement sheet industries, which results in cheap, inferior products coming into the market based on low pricing points. You can't make a cheap magnesium high-performance board. I've looked at it, you can't. There is confusion within the MJO industry to what is a good and what is a bad MJO board. This starts with the companies sourcing the products, because they are only prepared to pay the cheapest price to the manufacturer, and you get what you pay for. Focus on propaganda surrounding rust and corrosion over the past 5 years has led to fast track to the inferior MJO-based products such as sulfate board, without any consideration of test data that refutes the suppliers and trading house claims. To stop the BS, we are happy to share the information which I've shared to you. A lack of knowledge and understanding of application of the product within the construction industry. Where are the independent engineering, test reports, compliance, certifications, installation reports? I can't believe people buy these products and don't even have an installation manual supplied to them by the supplier. Industry suppliers trying to write their own internal standards. We have this here in the UK and in Europe. E.g. UK and Mocha from Canada, for the use of magnesia board, the cement boards, to bolster so they're trying to write their own standards to bolster their position instead of allowing governments to independently champion such a standard like already exists in America under the ICCS magnesia cement flat sheet, which China adopted as industry standards in late 2018. There are already trusted third-party independent laboratories and agencies which we can all trust, such as Intertek, SDS, Warrington's. Where to now, 2020 and beyond? It is no secret that the building materials industry needs to change. We're all facing real change and challenges moving forward. The rug is about to be pulled out from under the feet of many in our industry in regards to having to show independent third-party testing, quality assurance as proof of performance of all protective systems. Not in-house opinions or in-house engineering. The word I'll give you again was independent third party. The past exemption clauses within many building codes have allowed for the interpolation of performances of a system are coming to an end. Watch this space. If you haven't already found that in Europe, it's coming. Australia has it. The deadline is 1st of May 2022. Failure to comply may see insurance companies refuse to insure buildings, and I did a spelling mate of this, and compliance approvals being rejected or withdrawn. We're already seeing in Australia compliance companies and certifiers go on site and rejecting the systems that have been installed. For our industry, we know that plasterboard drywall delivers different benefits to FC and OSB and MGO. That FC delivers different benefits to that of plasterboard, but not to that of OSB and MGO. That high performance magnesium cement products can and are offering direct replacement solutions to that of both FC plasterboard drywall products, all in a single multi-purpose product. In closing, I believe that not one glove fits all. That all these products have a place in the marketplace, and that will remain so. I know there are major advantages for those companies that are proactive in recognising the changes that are coming. I know of new exciting collaborations that are being formed between magnesia industry leaders, FC, OSB, plasterboard, drywall companies, and these collaborations are starting to deliver healthier, safer and stronger hybrid-based systems. This is exactly what our industry is looking for. So, by Dean Hughes, sometimes when you're looking for an answer, your search is everywhere. You'll search everywhere else before you take a look at what's right in front of you. My 2018 closing message was collaboration, and that's the same today. Thank you very much for your time. Any questions?
Thank you very much indeed, Steve, for a very interesting presentation. And we do have a couple of quick questions. The first of which is from Dirk Nietman, and he asks, if you talk about magnesia cement, do you mean sorrel cement, magnesium oxide or magnesium chloride mix, or forming magnesia silicate phases?
It's it's a new formulation away from sorrel cement. It's similar, but we don't go down the sorrel cement line. We're using different binders and different catalysts to produce the magnesia cement. The sorrel cement was too reactive and too rigidity in its formulation as it stood. And to come into a flat sheet board to work on exterior and interior linings, a lot of evolution had to be made to change that formulation and mixture. There's a lot of IP behind it. Happy to discuss that, but I won't get into tell what the Colonel Sanders mixture is.
Okay. And Javier Cruz asks, what is the availability of raw materials for magnesia cement?
If I said unlimited, I wouldn't be stretching the truth. The fact with the magnesia or magnesium material, for instance, I'm business partners with a company, and there's a Canadian company here as well. I'm business partners with West High Yield Resources in Canada. We have there alone over 300 years of magnesium readily available to us. China has the next biggest resources available to them, and then we go into Turkey. The big factor with the magnesite is not the magnesite. It's the grade of magnesite that it can be calcined when it's produced. So we have people say to us, we will come and open a manufacturing plant with us in Budapest. We have a magnesium mine. And I ask them, what is the grade of this calcine? And they tell me, we're not interested because we know the percentage of quality, purity we have to have. If you don't have the right ingredients, you're not going to make the right board. Okay, so it is unlimited, but it's the quality that needs to be calcined. I can take a magnesium mine in Alberta, okay, and if I have the equipment and the heat of the furnaces, I can get a magnesite to 100% purity, okay, pharmaceutical level. But most people can't afford to put in that level of furnaces. They only run furnaces that go to 700, 800 degrees C. That doesn't, let me tell you, it doesn't get to the quality you need to make the high quality internals. But there's plenty available.
Okay, are there any questions from the real world in the room? Okay, that's all the questions we have online as well. So we'll call it a day and thank Steve Marskell once again. Thank you very much indeed, Steve.
Thank you.